We're always trying to improve our instruments, find new ways of improving the way that contact angle measurements can be done. And in this case, we are in close contact with some customers, and we heard about, well, it's difficult to place drops on very hydrophobic surfaces. It's also difficult to sometimes compare results when different people perform the measurements.
So everybody and his uncle can do a contact angle measurement in his kitchen. But do those results compare then? Very often not, and that's then frustrating.
After some investigation, we found out that the dosing is mainly what can be improved or what can be addressed to solve those problems. And so, in contact with our customers, we decided to develop a new way of dosing, trying to overcome the problems that can be found when we dose with a solid needle.
We would normally achieve the mechanical movements through motors and complicated techniques, but we attempted to design them completely differently. That's how we came to the idea of the liquid needle. The deposition process, which is usually mechanical, is now induced using a jet of dosing liquid. This has allowed us to save a lot of space in the mechanical areas. We don't need motors. We don't need any moving parts in the instrument, which also makes the instrument more robust. And that was the approach, the core consideration, which brought us to the liquid needle.
The problem is that you get different results, different contact angles when you introduce too much kinetic energy into your drop. And that's where lots of our development work went into.
To do that, you need to precisely check every parameter, which means that from pressure creation to pressure regulation and the diameter of the dosing nozzle, everything must be precisely tuned together to make that possible.
And this is then the beauty of the new technique or the new device that was developed at KRUSS, that it is designed such that this excess energy is minimized, that it becomes completely negligible in terms of contact angle. When you come up with something very new, in an old field like contact angle measurement, optical contact angle measurement, 200 years old, I think you have to prove for your customers, but also for ourselves, that it really works, that it really gives you the same contact angle result. That's why we said, okay, let's start with a thorough experimental study comparing the contact angles measured on different substrates, a wide range of different substrates, but with droplets deposited with two different techniques.
Customers come up with all kinds of different surfaces. They ask for smooth silicon wafers, very homogeneous. They ask for glass samples, for technical polymers are most widespread. We put into the software the parameters to make it as comparable as possible through all the different surfaces.
So with this broad range, we covered really a lot of applications. And for all of them, we found that the results are comparable.
On all the samples we tested, liquid needle and the classical needle system gave you the same contact angles. And we found this is a very important result because this is different to all the alternative dosing techniques that have been introduced before.
That's why we decided to submit the whole study to the Journal of Colloid and Polymer Science in the topical collection Contact Angle Hysteresis to make it accessible to the public, giving all the information how we did the experiment so that even people can redo it.
It runs through a peer review process, which means that people who know about contact angles, who are expert in this field, they check our results and they give us feedback on our results.
The liquid needle is such a beautiful device because it is so quick and so reproducible. Here at KRUSS it is already the standard technique, and I really invite all our customers to think about if this could be really a nice new standard way, because of those advantages that you have a well-controlled and quick process, giving you even more confidence in the contact angle data that drop out of your instrument.